So when we have a planet here, especially our Earth, and when we look at it and we have, we've got a plate right here, we strip everything down from the Earth and we start looking at it and we notice that, hey, it kind of looks like a big soccer ball. Then something is going on. We're not so interested in the plate right here just because, well, no, not necessarily. We don't get a lot of information from the inside of this plate. We can get some information from there, like Hawaii, we can see what's going on with Hawaii, but other things we don't have a lot of information. It's kind of the same idea. Right now, you're probably not aware that you're traveling about 800 miles an hour that way. Okay? Whole building is, everything in this room is, and that's because you live on a globe that spins, that rotates, and as it rotates at the equator, objects that are on the equator are traveling about 1,012 miles an hour, around and around and around. Since we have a shorter distance up here, we're traveling maybe around 800 miles an hour. But you don't notice it because you're on the planet, you don't see anything really weird. You do see the sun rising in the east and setting in the west. But if you didn't know any better and you weren't taught that we spin, you would think the sun was going around us. And in fact, you'd probably think all the stars were going around us. And we can actually calculate how fast those things are going and figure out how fast we're moving. It's not until we see the actual perimeter of the Earth that we start to realize that, wow, okay, we're spinning. We're moving really fast. And the same thing is true as even if you were, well, have you ever been on those human movers or at the airport? I love those things. They're like half a mile long, that big conveyor belt, you're walking on it, and all of a sudden it's like, yeah, you're like moving like really slow, and then all of a sudden it's like, you're going really fast, and then when it stops, you're like, oh, tripping, and you're dragging your luggage with you too, right? And you turn around and go the other way, and you're like, you know, and like, man, I've been walking in the same direction for an hour and haven't gotten anywhere. Okay? If you're looking down at the treadmill portion, it doesn't look any different to you. You just look like you're walking normal. And it's not until you actually look up and out that you're seeing people like, zoom, zoom, you know, going by and you're like, wow, I have superhuman. Well, that's so cool. I wish I could always do this. And then you go the other way and maybe you've been on a treadmill running and like, man, I've been in this place for the last hour, and you're looking around and you're still in the same spot in your room you've always been. Even though you ran 5 miles, you've gone nowhere. It's not until you actually start looking around that you realize whether you're going somewhere or you're not going somewhere. Well, the same is true for here. If we're in the center here, we're probably not going to get a lot of information on what the plates are actually doing. So where do we want to look? We want to look out on the sides. We want to look out. And that's where we're going to see everything, and that's what we're going to talk about next. These are called plate boundaries. And we want to focus our thoughts on this here for the next little while. So we're going to talk about plate boundaries and talk about what's going on with them. Now I know geography, I thought geography actually went into this a lot more in depth, but it sounds like they don't. You're probably aware of the different types of boundaries. You've probably heard of convergent, divergent, transform. Yes? No? You did this, right? Like, oh yeah, that's a transform. Oh yeah, that's convergent. Oh yeah, move away, that's divergent. We're going to get into a little bit more detail about it. So we want to look at plate boundaries. And find out what in the world's going on with all these plates. So the first thing we're going to look at is we want to see what is driving. What drives the plates to move. So we're going to draw a section of the Earth here. And this section is underwater. because we're looking out at the Atlantic Ocean. There and over here is some land. And here's the water. And deep down in the earth we have what? The core. And we know the core is nice and hot and toasty. It's producing a ton of heat. And that heat is going to start moving and migrating away from the core. And now, what do you think it's going to end up doing to this mantle? It's going to get it hot. And as it gets really hot, it will it will heat up. It's not going to melt completely, but it's going to start to become a little bit more fluid. This stuff will start rising, and it ends up over in this section right and through here. Now, once it gets up there, it only has a few places it can go. This does have a split in here, and some of that stuff does go up in between the earth and or the mantle and the crust, and we have these volcanoes down and through here. But that's a very small little crack, and a lot of the stuff isn't going to be able to make it out. So it starts migrating across this way. And as it does so, as it moves away from this place that's nice and warm, it will begin to cool down. And as it cools down, it becomes more dense. So it cools. It becomes more dense. And since it becomes more dense, gravity is going to start pulling this thing down, and it sinks due to gravity. Well, as that stuff sinks and comes back down here, what do you think it's going to do to this material here? It's going to do what? Thank you. It's going to push it up. And that's true. That's the way density works. Okay, one of the things I hate the most. Ugh, I hate it. Is I feel pretty strongly about it then. I don't like walking barefoot in water that has that mucky, gucky mud in it. And when you walk in it barefoot and you can just feel the mud oozing up in between your toes. I know some people are like, oh, I love it. I'm like, ugh. It just, it's, to me, it's gross. I don't like, it's like you sit down and so, there it goes, and it's gross. I don't know what, I have no idea what is down there, what's going on in between. I don't know, maybe it's a worm or something. I don't know. It's, ugh. Okay? I don't like that feeling. But the reason why that mud oozes up in between your toes is because you're more dense than the mud itself. And when you step down to that mud, the mud's got to go somewhere. So it gets forced up because it's less dense than you. When we have heavier material like this that sinks, it's going to force this other stuff up like that mud. Because, one, this is hot. Two, it's less dense. And it is forced upward. It rises. So it will rise up to the surface, and this starts moving upward. Do you know what we call this? It's a convection current. Good. This is known as a convection current. Good. That is a convection current. Now, we know this is going on. We know that this has to be a part of why these plates are moving. We know that when we look at the ocean, we know this plate is moving this way, and we know this plate is moving that way. The question is why is it doing that? Here are the reasons why we think it's happening. We know that this current is moving out and away, and we call this the conveyor belt. Conveyor belt. Because as this moves across, it's going to pull things across like a conveyor belt. Yes. It's going to move across like a conveyor belt, but one of the problems is the rate that this plate is moving and the rate that this material is moving are two different rates. They don't actually travel at the same speed. So we know there's got to be something else that's going on here. Watch this. So we're going to say that this is the slab that we have here. And if I have this rock or whatever it is right here, and what would happen is if I pushed this part up. it would slide down, right? And what would happen if I pull this part down? The same thing happens, correct? Okay, we believe that something similar to that is happening with the crust. We have all of this material that's going up, and it pushes up on that ridge. So we call this ridge push, which means that this material pushes up on that crust, gentlemen, pushes up on this crust, and it wants to start sliding down. Gravity pulls, this is called the slab, so gravity pulls on that slab, and we call this slab pull. Starts pulling this down. So not only do we have this material pushing it up, but we have gravity pulling it down. This plate is going to start sliding down towards the center of the Earth. So what's causing plates to move? We can say three things for sure. Number one, convection currents. Number two, gravity. And three, ridge push, slab pull. These are the three things that we think is going on, causes all of this stuff to move. This is the driving force behind that. Now I'm going to erase this and I'm going to redraw this again so we've got a clean slate. We want to talk about this boundary. This is a boundary. It's known as a divergent boundary because it's splitting in half. So let's take a look at this and let's see what's going on at a divergent boundary. So plate boundaries, first one we'll look at is a divergent boundary. And a divergent boundary sounds just like, well, to me, what it is. It's going to diverge, which means it's going to move away from each other. So plates move away from each other. So let's draw a couple plates here. We're going to draw the Atlantic Ocean. So we have the United States or North America. We have Europe. And then we end up with some mountain ranges down through the middle of the ocean. This thin crust. We have water right up through here. And we have this split right here. We know one crust is going this way. Another one is going this way. You want me to draw this three-dimensionally? So you can see it? Alright. You don't have to, but I will. Well, thank you.
I couldn't even draw the first one.
Okay, that means that right down here, there is this nice little crack down underneath the ocean that has volcanic activity. We have mountain ranges all down and through here. And this plate is moving in this direction. And this plate is moving in this direction. Can you see that? That work? Okay, so this is splitting apart. Why is that splitting apart? Well, we told you why. This stuff moves on up, gets over here. It's going to move that direction. This one's going to move over this direction. And it starts splitting apart. What do we know about a divergent boundary? We know it's moving apart, but there's a few other things that we know about this. This is the only boundary that does this. Forms new crust. This is the only place where new Earth is being formed. New crust, right here. So if this was the Atlantic Ocean, then what do you think the ocean's doing? Is it getting bigger? It's getting bigger. It's getting wider. It's going to keep moving away and getting wider and wider and wider. No, because water from other parts of the globe will move around into those empty places. Water always tries to find the lowest point, and it always trying to balance itself out.
Yeah, but can't you not ever get more water on Earth, so it'll eventually get lower?
Only if it freezes. But no, it will just move around from one place to another. Let me ask you this. You ever done dishes in the sink? Lots, right? So you have a sink full of water. You take a bowl and you put it in. I know you've done this. You take the bowl, you start pushing it down, and it's all empty. And then you go down, and all of a sudden the water goes, it fills it up, right? Until it's all flat. Same thing is going to happen here. As these start moving away, water from the Pacific Ocean, water from down in the Indian Ocean, water from all over the globe starts balancing itself out, and it will fill this up too. As objects start pushing things away, the water will just move out of the way and fill up somewhere else. And in this case, it will fill up here. Yeah?
Does that mean we're going to end up towards that way?
Yes. Okay. We'll all be back together again.
What? But won't it be backwards?
Well, it won't look the same, will it? The Earth never has looked the same. We haven't always seen, the United States hasn't always had that shape. We've had all the continents all in different directions. I mean, it changes shape all the time. Africa is changing shape right now.
But when there was Pangea, it was us or South America touching.
We would have looked like just a great big landmass.
So that's what was touching was South America and Africa.
But there was no boundary then.
Apart this way, so we can come back that way.
Ideally, yes, but not necessarily.
So, it's always bothered me, but in the ocean, can you swim under the United States? Because how does it sit there then?
Because it sits on top of the oceanic crust.
It comes up. It's connected to the bottom.
See this? This is continental crust right here. Okay? This right here is continental crust. This is oceanic crust. They're two separate crusts. This crust acts just like ice cubes in a glass of water. This stuff here does not. It wants to sink. It's light enough that it can stay on top of the mantle, but it's heavy enough it won't go on top of this. So it stays in between. This stuff eventually does go back down. This stuff won't. It will always float around. So it's like, think of it this way. If you were in a bathtub and you had a bunch of soap bubbles, or a sink full of water where you're doing addition a bunch of soap bubbles, you could pull the bubbles apart and have two different shapes, but then we can always push the bubbles back together and get a different shape. We can constantly be changing the shape. Well, when these crusts come back together, they'll become one landmass again. And if it happens to split and then a part of that landmass will move, then we'll have a whole new shape. They're constantly moving around and colliding into each other and breaking apart and splitting apart. Yes, they will. We've already done this 2 or 3 times already. And it's going to happen again, and it will happen again, and it will happen again until the Earth is dead. Until none of this happens anymore. As soon as that stops, then the continents will stop. They'll stop moving. And once they stop moving, they'll be permanently frozen in time in that place forever. But as long as all the earth inside is moving around and doing what it's supposed to be doing, the continents will move and do what they do too.